All right, let me answer another one here. This is from chapter 36, number 54. And if you got a chance to look at that, you'll see that there is the object, and so I'll make a little arrowhead here. And then 1 meter away is a lens. And so 1 meter away, we have our lens. And in the reading, they say that the lens has a focal length of 80 centimeters. So the light will go through this first lens and make an image somewhere. Where, I'm not sure, but I do know that there is a mirror then, a convex mirror, so it's going to have a negative focal length, and they say it is 50, so it's negative 50 is the focal length of the mirror. And that mirror is 1 meter away from the lens. And the question is, state whether the final image is either upright or inverted, and what's the overall magnification. And so the key to any multiple lens or multiple mirror lens system is to say that the first one creates an image. That image then becomes the object of the next one. This one's a little tricky, and to realize that the light's going to come from the object and it's going to make an image. So we'll call that image number 1. Maybe it'll be right here. I don't know yet. But it'll make an image. Then that image will then become the object for the mirror. So the light's going to hit the mirror. And so the mirror redirects it. And so that'll make a second image. Let's say it makes a virtual image, maybe right about here. But this one we need to be careful, because as the light bounces off the mirror, appearing to come from here, let's say. Again, I don't really know where it's going to be yet, but I will calculate it. I want to point out that it would go through the lens again, and so this actually involves 3 optical elements. We go through the lens, then the mirror, and then through the lens again. So let's start off with our first step here and see if we can figure out where is the image from the first lens. And so I'll put here a 1/1 for an object distance of p. I would like to find out what q is, and the f, as they say, is an 80. Better be careful with my units. Why don't I put a 100 here for my centimeters? So I'll change this to 100 centimeters. And 100 centimeters, so that I'm in the same units. And so this is 1/80. So to get the q then, I guess I would have an 80 reciprocal, and then minus a 100 reciprocal, and take the reciprocal of that. And so that's 400. And so the first object is 400. Notice it's a positive. So that means that way over here, so if this is a 100, then we would have to go another 100, another 100, another 100. We're way off the screen here. And so the image would be formed, I'll just put way over here, but I think it would be even further than that. But maybe I'll just say image number 1. And that's where it would form if it hadn't hit the mirror in the meantime. But of course, it never actually forms there, because the light comes in and hits the mirror way ahead of time. And so as I continue on then and say, okay, this is the lens, and I'll say the lens the first time, let's look at what happened when it hits the mirror. And so if I go 1/p, let's move this over here. And so if I go 1/p plus 1/q equals 1/f, then I've got to put in my object distance. And then that's where, and this is a good example then of a virtual object. This is when p can get negative, because if this is 400, that means from this lens to here is 400. that means this distance is 300. So I need to put in a negative 300 for the object distance. And so where is the image? And then, of course, the focal length is a negative 50. And so if I solve this for Q, let's see, I would have a negative 50 reciprocal. And when I bring that over, it becomes a positive 300 reciprocal. Hit enter and take the reciprocal of that. And we're looking at a negative 60 centimeters. All right, so again, the key here is the negative would tell me what side is it. And for the mirror, remember the definition of a negative for the Q is the side the light doesn't go on, and then so the light hit here and bounced off. So this side is positive Qs, this side is negative Qs. So we're talking about a distance of 60, and I don't think it will invert it. I really haven't done the math on that yet. So I'm going to draw it downward and see what ultimately happens. I noticed I inverted this one too. That was more of a guess than a proof. So maybe I should prove that here in just a second. So I think I will. But anyways, I just wanted to point out where image number 2. So somebody standing over here looking at this mirror after the light has gone through this lens, bounced off, and comes back. But before it goes through this lens, so somebody standing in this area, not way back here, but someone standing in this area, as they look back, the light would come to them and it would be appearing to come from right here. Now, to decide whether it's upright or not, maybe I should go back to the lens and say, okay, let's look at the magnification, which is minus Q over P. And so this would be minus a 400 over a 100, which is a negative 4. And so this first magnification from this lens is negative 4. That's why I drew this one upside down. And I probably should have drawn it much, much bigger, because this one here should be 4 times bigger than this first picture. But not worrying about the scale of the drawing, then when I go to magnification number 2, I'll call that 1. Number 2, again, the minus Q over the P, the negative of negative 60 over the negative 300, okay, is overall a negative. And let's see, 60 over 30, I'll just drop off a 0, divide by 6, that's 1 over 5, right? So that's 1/5, and it's a negative 1/5. So it is inverted from its object. So yeah, that one caught me off guard. I thought it was going to be a positive magnification. And it would have been if we hadn't had a virtual object. That's what messed it up or changed it from what usually happens with a concave mirror. When we have it by itself, it just makes it smaller with the same direction. So with our object upside down and then with a negative multiplication or magnification, then it's going to invert it and make it 5 times smaller. So from here to here it got 4 times bigger, then from here to here it's 5 times smaller. So overall, my image right now is smaller than what we started with. Okay, but still haven't completed the problem. Because again, as I said, if somebody was standing right here, looking this way, so if the light had come through the lens, bounced off the mirror, and went to the person, this is what they would see. They'd say, okay, this is where the object is, or that is, it would appear to be this. So this is the image. So image number 2. But we need to complete the problem by saying now, this light is not going to be viewed by this person. it's going to come back out, and I would assume that they are implying that the viewing person is over here. So the light needs to get redirected yet again a third time, and so we've got our 1 over P plus our 1 over Q equals our 1 over F. And so in this case, we need to put in the object distance. And so this second image then becomes the object for our third optical element, our lens here. And so this is 100, and we just said this would be 60. Granted, we listed it as a negative 60. But now that's total distance away. The image is actually light coming from this direction. And so it looks as, this is all positive. So this would be 160. This would be a distance of 60 and then 100 more. And so the light coming to this lens, as it's coming at such an angle as if, or in such a formation, as if it's coming from this point. And that's 160 away. And the focal length is 80. So I think that makes 320. Isn't that a 2-to-1 ratio? Well, let's see. And so 80 reciprocal minus 120. There's the 2-to-1 ratio. And then take the reciprocal of that. And, oh, yeah, my bad. 2-to-1. Okay, so good. 160. Yeah, so 60 is a 2-to-1 ratio like that one. Okay, so this is the location. And again, notice it's positive, and it's our final location. And so that means the light at this point is going this way. And so where the light goes to is the positive side for the Q. So this is the positive. So 160 would probably be right about here. That's 100, and that's 160. And if we look at magnification number 3, this would be the minus the Q over the P. And so the Q is 160, and the P is also 160, and so that's a magnification of -1. So that would invert it from what it started at. So looks like all three of them have a negative magnification. So we start upright, the first lens inverts it, and then the mirror inverted it to make this image, and then finally the last step it inverted again, and so overall it's inverted, and that's part of the question. Is it upright or is it inverted? And then to finish the magnification, and then we can say it got either bigger or smaller each time. And so the total cumulative effect is the three multiplied together. It'd be like saying, what if I doubled something and then I tripled something and then I quadrupled something? What would be the total effect? Well, if you double it, you multiply by 2, and then you triple it times 3, so that's 6. Quadruple it is 4, so it's 24. So the overall effect is it's 24 times bigger. So in our case, we're looking at its first magnification right here is -4, and so it's bigger by 4 and upside down. The third time it is inverted again, so it's negative but made smaller by a factor of 5. And then the last time it's inverted again, but 1, meaning it doesn't get bigger or smaller, it just inverts it. And so that's why we have a negative 4/5 for the overall magnification of this. And so that's the final image is upside down and about 80% then of the original size. And so this person standing on this side would, see, of course they still would see the original object, but then they would see what looks like one a little closer to them in my picture, and a little smaller and upside down. And voila.